Hello and welcome to HTML Smuggling, the 15th video as part of our Red Team Fundamentals mini-series. In the previous video, we discussed the concept of phishing, where we implemented our own phishing infrastructure that was capable of sending out mass phishing emails with the capabilities of capturing credentials. Now, most of the time when organizations wish to perform mass phishing campaigns, they will typically look for such evaluations with a report at the end of the assessment that shows which users and how many of them fell victim to a phishing attack. The organization can then take that report and act upon it. However, many phishing campaigns, especially when the primary objective is to gain a foothold within the organization's network, will be much more advanced than that. And we will typically have to use some advanced techniques in order to get the user to run some code that will call back to our C2 infrastructure, landing us a session. Now, this can be very difficult to pull off, especially when the organization is mature and has significant defenses in place. One other challenges that we will inevitably encounter is how we are going to deliver such payloads. Given that the only possible interface of interaction that we will have with our victim is email, and the increased security implementations within them, this can prove quite a troublesome problem. There are numerous techniques that we can leverage for such activities, and it really relies on how creative we are at constructing them. One of the most widely known techniques for payload delivery is HTML smuggling, where payloads are delivered through external references rather than email attachments themselves. And as we will see in this video, this technique is still very capable, especially when creativity is involved. As per usual, everything that we teach in this video is purely for educational purposes. We are not responsible for your actions. So, one of the oldest methods used for payload delivery, which is still very common today, is the use of email attachments. Emails that are distributed to victims would contain attachments within them, often with instructions that influence the user into downloading them and launching them. However, with this approach, especially in today's standards, there are several drawbacks, mainly being that attachments are more prone to analysis by security measures such as SEGs, which inspect and filter email traffic by using a combination of signature analysis and machine learning. This means that if our payloads are not well obfuscated or contain known malware signatures, our attempts to leverage our chosen victim may be jeopardized entirely if they suspect and report that email as malicious. There are numerous ways to overcome such payload delivery obstacles. However, by far the most common and customization capable technique is HTML smuggling. With HTML smuggling, payloads are no longer delivered as attachments, but pretexts are developed where a user is typically instructed to visit a website in which our placed payload would then initiate an automatic download. So instead of requiring users to manually download an attachment from an email, the payload is automatically downloaded for them with the help of JavaScript blobs. Now, we will get into JavaScript blobs shortly. However, with HTML smuggling, we have the ability to serve payloads through links that are attached to emails. Now, because those links redirect to websites that are hosted by us, we can customize those websites as we please. Moreover, as payloads are instead served on websites we own, this lifts the common scrutiny that is applied to attachments, meaning that we have more likelihood of our payload landing on the victim's disk. Of course, assuming that we have taken the necessary precautions beforehand, such as aging and categorizing our domain, etc. So to kind of illustrate what HTML smuggling entails, the interface that you are seeing is from the perspective of a victim. So this is the landing page that the victim will be redirected to once they fall victim to our phishing attack. Now, of course, I've made this website as quickly as I can, but the fundamental principle that we're trying to understand here is, what HTML smuggling is. So in a traditional sense, when a user visits the website, they will be instructed to perform a download. And as is the case without HTML smuggling, the user will have to click on some sort of link to initiate that download. So as you can see here, I've added a download button that downloads a exe file on the victim's disk once they click on the link. So as you can see here, once I click the link, the download initiates and is stored on disk. Now, one problem with this approach is that the user has an extra step that they need to perform in order to initiate a download. So the user will be instructed to perform a set of actions which will get them to initiate a download. And during the time frame that the user is performing those actions, they may realize that, the pretext that they fell for is malicious, and thus they could terminate their actions of initiating the download. Now, in the case of HTML smuggling, it takes away from the fact that the user has to manually initiate the download. So to illustrate this, I've updated the code to include a HTML smuggling payload, and as we refresh this website, you'll see that the link is, disappears because I've removed it, and then the download initiates automatically. So as we mentioned earlier, HTML smuggling depends on JavaScript blobs. And at the most fundamental level, a JavaScript blob is a container for an object stored in its raw, binary, immutable form, that is zeros and ones. Most of the time, JavaScript blobs will be used when handling file-like data, such as images, videos, and form data. And numerous web APIs will typically not operate directly on the data of such files, but instead operate at the binary level, as it's far more memory efficient. Now, from the perspective of red teaming in our case, JavaScript blobs can be used to store payloads in their binary form, which can then be reconstructed automatically on the fly within the victim's browser. Now, what's more is that blob objects are stored entirely in the browser's memory, which enables us to work with file-like objects, i.e. payloads, without having to interact with the underlying web server itself. Everything is conveniently loaded into the client's browser and subsequently reconstructed with some basic JavaScript code. So for this to make more sense, let's take a look at this concept in more detail with some practical applications of JavaScript blobs. Okay, so in the following code snippet that you are seeing, we essentially define a new blob and print out its common properties. Now, you can run this code snippet yourself. I suggest that you rewrite it and follow along with our demonstration. And then to execute it, you can use either Node, or you can actually use an online interpreter as well. Okay, so going back to our code snippet, one of the first things that you will see is the definition of a variable named data. And all that it simply holds is an array containing the string hello world. Now, the reason why we are using an array rather than a string is because this is the requirement for the blob constructor that is used to initialize blobs. So if we go down here a little, you'll see a list of parameters that the constructor expects. And one of those parameters here is called blob parts. And what blob parts expects is simply an iterable object such as an array. Now, additionally, you can specify a set of options which essentially dictate how the blob object will be constructed. More specifically, the type property indicates the type of data being stored as a blob. And as you can see here, within our initialization of a new blob, we are storing the type as text plain. And essentially the text plain MIME type works for our string example that we stored within the data array. Now, although this is optional, it is indeed a crucial specification because by default, the value will be empty. And when initializing a new blob, the blob object can misinterpret the data being stored. So to ensure that the data is being correctly stored, we define the correct MIME type for the data that we are storing. And in our case, text plain aligns with a basic JavaScript string. Now, another property that we can specify is endings, but this is an optional property and is not really relevant in our case. Now, once the blob object is initialized, we simply log the blob object itself to the console. And then additionally, we log its size and its type. And you can find these properties and what the values they hold within the instance properties section here. So essentially, size should return the size of the blob interface in bytes. And then the type property should specify the specific MIME type of the blob object. Okay, so I hope this cleared everything up. In order to now execute this little code snippet, we can simply run a node and provide it with the script. So once executed here, you can see we get 3 of our console log outputs. And this first line that we are printing essentially logs the specific object. So in this case, it is a blob object. And then also you can actually see the properties of the object within it as well. The second line we are outputting is the size of the blob object. And in our case, it is 12. And this aligns with the string that we define here. So as the string contains 12 characters, we receive the output of 12. And then lastly, we log the specific MIME type of the blob itself. Now, I know all of this can be a little bit confusing if you're new to JavaScript blobs. However, the main thing to understand here is that by creating blobs of our own, we can store payloads and then subsequently reconstruct them on the fly. And this will make more sense as we begin to develop a HTML smuggling payload. Okay, so recall that the fundamental principle of HTML smuggling is the delivery of a payload. Now, this is where JavaScript blobs come in. By storing our payload directly within the script that we are serving, we can use a JavaScript blob to subsequently reconstruct it. Now, one of the challenges with this is how are we going to store the payload? Now, there are several methods in which we can store the payload, but by far the most common method or way to store something within the web is by using base64 encoding. So by taking a given payload's binary contents, encoding it in base64, decoding it back to binary by leveraging JavaScript functionality and storing it as a JavaScript blob, we can serve payloads directly to the victim. Now, to achieve this, I've written a set of JavaScript code that essentially performs all of this for us. Now, our payload will be stored within the encoded data variable, and essentially we will be storing it already base64 encoded. And then that payload will be passed into the base64 to array function, which will be returned as a bytes array. Now, the base64 to array function accepts a single parameter, and that is the encoded data. And remember, that is our payload. And the function will begin by decoding the base64 encoded payload into a binary string where each character will represent a byte from 0 to 255. And this is achieved through the A to B function or attrib function, which simply accepts a single parameter of a base64 encoded payload. So if we take a look at the documentation here, we can see that the A to B method of the window interface decodes a string of data which has been encoded using base64 encoding, and it will return a binary string containing the raw bytes decoded from the supplied parameter. So essentially the variable binary data here will contain the binary string of our payload. Then we are going to calculate the length of the binary string and create a new byte array from it. So as you can see here, the uint8 array creates a new unsigned integer array that is the size of the length value that we calculated earlier. And keep in mind that this array will store the binary contents of our binary string. Unfortunately, there is no method to convert a binary string into an array automatically, so we have to write this functionality ourselves. And then we create a for loop that iterates over the binary string and copies the character code or the byte value of that character code into the array. And then lastly, we return the underlying array buffer. And by the end of this function, we should have an array that holds the binary contents of our supplied payload. Next, and this is the most important part, we create a new blob object from the byte array. Now for the type where we previously specified text plain, now we are specifying application octet stream, which essentially specifies that the blob object is holding a binary set of content. Now the payload that is being downloaded will need a name. You can be as creative here, but we use the name of our own. Now in order to automatically download our payload, we will have to create a new anchor element, which will then be signaled with a click event. And the way we do so is simply by using the create element function, appending that element to the document's body, and then we hide that element by setting its display property to none. Now we cannot actually serve the JavaScript blob as a file, and instead we have to create a temporary object URL that points to the blob. And then this URL can be used as part of the anchor that we created to download the blob's contents. So if we take a look at the documentation again, we can see that the method is described as creating a string that contains a blob URL pointing to the object given in the parameter. parameter. And a blob URL represents an in-memory resource that can be downloaded just as files can be. Once the URL is created, we simply assign the href property the value of that URL. And keep in mind the href property points to a given resource, and that resource in our case is a JavaScript blob object. And then we set the file name for the download and use the click event to automatically trigger a click on the anchor, which will initiate the download. And then finally, we have the revoke object URL, which simply cleans up the object's URL to free memory. And once revoked, the URL becomes invalid. This is simply best practice. However, now that we have our functionality implemented, we will need a payload to serve. Now, to do this, I have already generated a payload, and this is simply a generic Sliver implant. So what we will need to do is cat the contents of that payload. Then we will take that payload and pass it to the base64 command. And additionally, we will use the W switch and a value of 0 to remove line wrapping. And to avoid manually copying the provided payload in base64, we will simply pass it to the excel command with the B switch that will copy that payload into our clipboard. Okay, so performing this command and pasting it within the encoded data variable. It might take a while here as Vim is quite slow. However, once done, our payload should be stored and be ready for serving. So with everything understood, we can simply save the file. And to confirm that everything is running as it should, we will start a Python HTTP server. And if we navigate to our server now, we should see that the download does indeed automatically start. And with that, we've implemented our HTML smuggling payload. Now, in case you want to, you can find the complete source code within our GitHub repository, and I'll leave a link to it in the description below. But simply, it just contains the source code for the HTML smuggling payload, and all that you really need to do is replace the encoded data with your payload that has been encoded in base64, and also the payload file name. Now, I suggest that you do some research and take a look at some methods in which you can improve this initial payload, and whatever method you find, do let us know in the comments down below. And that will do it for HTML smuggling. Honestly, it is a very powerful technique, especially when some creativity is involved, which realistically is what red teaming depends on. So as we proceed into our next video, we will actually take a look at several methods that, when chained together, serve as a powerful means of getting users to execute arbitrary code, as well as the capability of bypassing several detections whilst we are at it. Additionally, feel free to join our Discord, for which I'll leave a link to down in the description below. We have the launch of several of our products coming shortly, including virtualized labs entirely through Discord, and one of the best red teaming courses you will ever get your hands on. Until next time, stay safe and keep learning.